Recording is starting now. Okay, we haven't done anything yet. So now I've started the recording. I do want someone to remind me to record every lesson at the start. Does anyone want to volunteer to remind me to record every lesson? That just means during class at the start, just someone say, that person says, don't forget to record. Anyone want to volunteer? Okay, Farzana, good. Okay, you reminded me today, so that's perfect. You're the perfect person for the job. Okay, so Farzana, your responsibility is going to be to remind me to start recording the lesson at the beginning, okay? Oh, great, you're in both classes. Farzana? Yep, okay, great. Okay, so remind me at the beginning of both classes then. But if you don't come to class, then I'm gonna need somebody else. But if you come, hopefully you come to every class, and so then remind me. Okay, I could set the settings so that it just records automatically, but sometimes we do other things at the beginning or we wait. So I kind of don't have the recording on at the beginning. Okay, then I have to stop and start it. So, okay, let's get started. All our lessons are going to be on Word like this. So I think you can see what I'm typing. I asked the other class already, they said they can, but so I asked the question here, right? Can you read what I am typing, right? So can everyone read that on the screen that they're using? I'm seeing yeses, I'm seeing yes, okay. So I guess maybe a better question, can anyone not read what I'm typing? Can anyone, is there anyone who cannot read what I am typing? Yeah, I've said it out loud so you can hear me, right? So, but is there anyone who cannot read what I'm typing? Harman, you can't hear anything? Other people, can you hear me? Can other people hear me?
Yes, Professor, I can hear you.
I can hear you.
Great.
Professor.
Okay, great. So this is my second class tonight, so I think I feel confident in that my audio is working. So the reason why I'm asking that is that Harminder, I think it's on your end. The problem is on your end, right? So I saw you sign into two devices. So maybe that's why you're signing to two devices, right? So Harminder, you need to fix your audio. So I sometimes internet doesn't work. Or I don't know, technology is what it is, but this is, you need to fix your audio. Okay, so I typed that. You can't hear me, so you can't hear what I'm saying. So you need to fix your audio. Okay, so audio is a requirement for the course. Okay, so fix your audio. Okay, so but everyone can read what I'm typing on there. Okay, so I want to make sure because the Zoom is at 120 and I want to make sure we can read whatever I'm typing. Okay, so, oh, okay, good. Actually, before I do that, so you all got my emails, I'm assuming. I sent 3 emails. Each one of them had the same link on it. It was the Zoom link to this class and to every other class for the semester, right? It's a scheduled Zoom meeting link that enables you to attend every lesson and every exam. Okay, exams are during class time and they're on Zoom, just like any class day. So on a day of an exam, you just use the same link as you did today to come to class, and on the Zoom meeting, I'll give an exam, okay? I'll go through how an exam is proctored and all of that a little later. But my first point is just making sure that everyone knows, right? You're using that same link to attend every class, and you have it because you're here, right? So save that Zoom link that you used for today. So you use the link to get here. Take that link, copy it, paste it, put it somewhere, have it saved, and so you can always join class and easily, right? If you didn't delete the email I sent you, you still have it, right? So you can go back to that email and get the link and save it. Okay, so make sure you have the Zoom meeting link. For today, it's the same one for every day of the semester class. Okay, so that's covered. I sent another email. The third one was today, earlier today, right? So I think this email reaches, this link reaches as many people as I can reach. If somebody didn't get it, then there's no way I could have possibly given it to that person. Okay, great. Okay, so I think you're signed in 2 places, but before you were signed to 2. So maybe you have your phone on one and your laptop on the other. I've done that before. So, so however you decide to do it, make sure that whenever you're here, you have audio and you have video. If you need to do 2 devices, that's okay. But just make sure between all the devices you're using, you have audio and you have video, okay? During the exam, you can also do that, but it has to work. You have to make sure it works. So whatever method you're using to have both video and audio, it has to be reliable. Okay, if you're using multiple devices, you can, but that method has to be reliable. It has to definitely work on the day of the exam. Okay, you need to make sure that there isn't a problem with the way you fixed your problem on an exam day. Okay. 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 So word is on the screen. This is where lessons will take place. Also in the emails I sent you, I was talking about how Blackboard is now available, right? So if you go to the Queens College website, you access Blackboard through there, or you get Blackboard however you want to get to it. You put in your screen name and password, you sign in, right? And so on Blackboard, there's a list of classes on the left side. You choose this class from that list, right? And you end up here, right? So this is the Blackboard page for this class, okay? Anyone here not know how to get to the home page, how to get to Math 231 Linear Algebra Fall 2021 Blackboard page? Anyone not know how to get to this point? Who's here? Okay, so I'm assuming that everyone can get to this point where they can access the Blackboard page for this course. Okay, good. I also sent in an email. I also sent a link. I also sent like a picture of like how to use Blackboard kind of thing, and so that I think that could help you to get there also. But people are telling me that everyone can get here, so nobody's telling me they can't. So I'm assuming you can get to this point. Okay, so you're on the web page for Math 231, right? And so if you click the first link, which is Syllabus, there's a link here, and so it's Math 231 Full 2021 Syllabus. So you click that, and that's the syllabus for the course. Okay, so let me go to it. Here's Syllabus. Okay, so when you click that link, it'll bring you to the syllabus. So I'm going to put the syllabus on the screen. Okay, so here we are. So this is the syllabus for Math 231 Fall 2021. My name is Michael Pendezis. Hi, nice to meet you. Class hours are every Tuesday and Thursday from 8:00 p.m. to 9:50 p.m. Okay, there are a few days where the college is closed during the semester. If the college is closed, we don't have class on that day. But whenever the college is not closed, which is most days, it's every Tuesday and Thursday from 8 p.m. to 9:50 p.m. until the class ends. Okay, the room, it's on scheduled Zoom meetings that begin at the start of class, right? So we're not meeting in person, we're meeting online. And so our classes are from 8 p.m. to 9:50 p.m. on Zoom using the scheduled Zoom link that I've sent to all of you and that brought you here today. The office hours are every Friday from 2:15 p.m. to 3:15 p.m. on Blackboard Collaborate Ultra, except for certain days where the college is closed. And on those days, on those weeks, I moved the office hour to another time and day of that same week so that you'd still have an office hour every week for this class, okay? I'll go into that more when we talk about other things. So I'm going to come back to this point, but just as a general piece of information, office hours are every Friday, except on days that have to be rescheduled from 2:15 to 3:15 p.m. on Blackboard Collaborate Ultra. My email is michaelpendazis2021@gmail.com. So that's the email I'll be using for this entire course. Okay, for this semester, the entire course. So if you ever need to contact me to ask me a question or anything, that's the email I want you to send me to communicate me with, okay? So this entire class has one email. And so that means that it's a very easy way, it makes it easy for me to communicate with all, okay? When I give exams, after the exam is over, you have to email me your answers, okay? And so the email that you will be sending your answers to and solutions, full solutions and answers, your entire exam, and that would be grading, is that email to that email address. Okay, so this is a very important email address. It's on the syllabus. It's also on professor contact info on the website. So there are two places where this email address is always accessible for you to see. Okay, so you can always find this email address again on the syllabus, and you can also always find it under professor contact info on Blackboard. Okay, but I'm telling you it now, so you also have it there. If we ever communicate an email, you will have it in your inbox or in your send file, right? So, okay. Calculator, it's a TI-84 plus at best. What that means is that on exam days, you are allowed to use a calculator. If you're using a calculator in the TI series, then the best calculator, the most advanced calculator you can use is TI-84 plus from that series. Okay, and so if you have a TI-85 calculator, you can't use it. If you have a TI-83 calculator, you can. TI-84, you can. TI-84 plus, you also can. Okay, if you have a calculator that's not a TI calculator, it's not in the series, then just tell me, and then I can look at the calculator and I'll tell you, well, first tell me by email or during class early, and then I'll tell you how I'll confirm with you whether the calculator is good or not. So I'm not saying that a certain type of calculator is bad. I'm not saying that you can't, I'm not saying you can't use another type of calculator. What I'm saying is that if it's not in the TI series, then I have to inspect it individually to know whether or not the calculator is too advanced. It gives you an unfair advantage, okay? So Terry, you have another type of calculator. We'll talk about that in the future, and I'll tell you whether or not you can use that in an exam, okay? Maybe after class at some point, you can hold the calculator in front of the video, and I can look at it, and I might ask you to do a few things on it and show me what's happening, and then I can decide whether or not it's a good calculator, okay? So Terry, so that's the answer to your question. After class at some point, I'll just, maybe after this one, I'll tell you whether or not that calculator can or cannot be used for exams. Okay, so if it's not in the TI series, I have to look at each calculator individually to determine whether or not it can be used for exams. Okay, textbook. The textbook for this course is Elementary Linear Algebra 11th edition by Howard Anton. Okay, you can search for this textbook online, and I think you'll find it. I found it in the past. I think you'll still be able to find it now. Okay, so if you just copy this and paste it into Google, I think you'll find it easily. You could probably find it, buy it also, but if you can get it for free, why not get it for free, right? So I think you'll be able to find a free version of this online, okay? And so you can use that, but make sure it's 11th edition, okay? So Elementary Linear Algebra 11th edition by Howard Anton. Make sure you get all of that correct. Don't use a different edition, okay? So they asked me what book is for each course, and so I'm pretty sure I used this textbook, right? So, but regardless, it's right here, right? So I'm telling you right here, that's the textbook, right? It's probably the same one. It should be, but I'm also saying it's free online, right? So you don't have to buy it. You may want to. You know, I like a physical copy of every book. If sometimes the books are like $3 and I can get it for free online, I might get a $3 version of it, but I wouldn't pay $100 for a book that's free online, right? I wouldn't suggest you do that either, but if you want, you can. Okay. The topics are the following. So there's 8 topics. Again, it's free. It's probably free if you go. You probably find it free online. Okay. So there's 8 topics online. There's 8 topics in this course. So the topics course pretty much match with the chapters. So topic 1 is on systems of linear equations and matrices, and it's sections. These are the sections in the book. So it's 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9. I thought about putting a dash, but then when I put a dash, sometimes people like, is it in between or does it include? So I just roasted them all out. So topic 2 is determinants, which is 2.1, 2.2, and 2.3. Topic 3, Euclidean vector spaces. And so that's 3.1, 3.2, 3.3, 3.4, 2.5, and so on. So you see how that works, right? And so next to each of those is in parentheses a test number. So that means that test 1 covers topic 1 and 2, and it covers sections 1.1 through 1.9 inclusive, meaning including 1.1 and 1.9, and it covers 2.1, 2.2, and 2.3. That's the material for test 1, okay? Test 2 in parentheses means it covers topics 3 and 4, okay? It doesn't mean just this topic. It means all the topics that it's next to. So test number 2 is in topic 3 and 4, okay? Test number 3, you see next to all 4 of these. So test number 3 is on topics 5, 6, 7, and 8, okay? So then, so that's telling you the material for each exam, okay? The exams during the semester are non-cumulative. So that means that when you're taking exam 2 on topics 3 and 4, I'm not asking you directly questions from topic 1 and 2, okay? So test 1 is on topics 1 and 2, test 2 is on topics 3 and 4, and test 3 is on topics 5 through 8, and they're separate. But they're not totally separate, which means that in order to answer certain questions in later topics, you'll need to know information from earlier topics. If you don't understand at all topic 1, you're going to have a lot of problems with later topics answering later questions. Okay, so if you're studying for test 3, you need to know the earlier topics in order to take the test for test 3. Okay, the questions are going to be from topics 5 through 8, but the material will depend on earlier material. Okay, so they're not totally separate. Okay, you'll need to know earlier topics. But I think that answers the question of what is on each exam, right? So I'm telling you here what's on each exam. Okay, so moving forward, if you ever need to know what material is for what exam, just go to the syllabus and it's right here. Okay, topics 1 through 8 separated into these 3 exams. Okay, I'm going to jump down to grading for a second over here. So so there are 3 test grades, 20% each, and there's a cumulative final, which is 40%. And so that means that there's 3 test grades, 20% each. So each of the 3 are 20%, and there's a cumulative final, which is 40%. Okay, and so that adds up to 100%. So your grade is determined by 4 exams. Okay, and so they add up to 100%. Okay, so are there any questions so far about everything I said? Okay, good. So this is all making complete sense, right? Okay, so okay, I want to add something here. So I'm going to add now while we're talking about it. There's course objectives. Okay, so I'm just going to put this here. It's just something the college wants me to say. It doesn't change anything about the course. It's just the goal of this course is to have students become more comfortable with mathematical proofs and get a sense of how abstraction of ideas leads to unexpected outcomes. Okay, so the objective of this course is to teach you how to do mathematical proofs and understand that. Okay. Okay, good. Okay, so are there any questions about that? It's just to give you an idea of that. Sorry, hold on one second. Okay, this is another thing the college wants me to add on, and so I'm just adding it on there for you. This is just about CUNY policy, about like students with disabilities and stuff like that. And so that is all there, okay? And so that's the syllabus. Okay, so for instance, if you go to Blackboard, right? You're on Blackboard, you click syllabus, and you click here. Let's see, you open it, and this will come up. Okay, so you have the course objectives here, and you have the bottom thing here. Okay, so that's the syllabus. Tests. There are 3 tests during the semester and cumulative final. You will receive a review sheet for each test to help you study. as well as a practice test with answers, okay? So you must let me know that you're sick and can't take the exam either before the exam starts or during the exam. You kind of let me know after the exam that you were sick. If we are communicating by email about your exam, you have to respond to emails I send you quickly to be excused. You must bring me a doctor's note quickly to make up the exam. Okay, I've relaxed this point. Okay, so during COVID, I'm willing to relax that. Okay, I'm willing to say that you can. I want you to, but it's I won't hold it against you. Okay. Okay. So that's that. So please bring your doctor's note. But if you can't, I don't know why. Maybe I don't know, if someone doesn't feel comfortable doing it, they can maybe get around that. But it's only because of the pandemic. Okay, so I'm being understanding of people when they're sick, and so I'm relaxing that requirement a little bit for you. Okay. Okay. So. Okay, so please bring me a doctor's note quickly to make up the exam. The makeup will be when you're feeling better. There's no extra credit. The way to improve your grades is to score higher in future exams, okay? Homework, I will assign homework problems and it's your responsibility to do them and ask questions about them when we go over them during class, or to come to office hour and ask questions about them there. Okay, so I assign homework. I'm not going to collect them. I'm not going to grade them. So the homework is for you to understand the material. I go over it at the start of class after it's due. And then if you have additional questions, if you want individual help with homework or its answers, or if you ask any question you want, there's office hours and I can help you even more there, okay? So I will go over anything you want from the homework at the start of class after it's due, and I will also go over homework or anything else during office hour. Okay, yeah, there's going to be, I will help you review before each exam. There's also review sheets, and so I will talk about the review more. But yeah, there'll be a review for each exam. Okay, good. Okay, let me, I'm back here. Okay, let's go here for a second. I had a million files open, so I'm clearing them out. That way I can, okay, good. Okay, so, okay, so the syllabus is there. If you go to lesson notes, so if you go to lesson notes, if you go to lesson folders, so for instance, lesson 1 notes is here. I'll usually put the date next to it. And so if you click that, all the files for lesson 1 will be there and you can access them in the future, okay? So give me some time after the class is over to put things up on Blackboard and YouTube. I have 2 classes back to back. And so when this class ends, I start putting up everything for both classes. So I need some time to do that. I'll try to do this quickly as I can. Involves loading two videos onto my computer and then loading them onto YouTube. So it takes a little time and doing this also. Okay, but basically you'll go to lesson notes and there'll be folders, one for each class day with the number of the lesson and the day it was on, date it was on probably, and you click the folder and the stuff is there, like the Word file and whiteboard notes if I use it, if I make whiteboard notes. Okay, good, it's recording, okay, good. And then I record the lessons. And so Blackboard usually doesn't let me, it sometimes does and sometimes doesn't. And it's not very reliable with posting videos on it. So what I did do was I have a YouTube channel with my name, Michael Pendazis, right here, Michael Pendazis. So if you go to YouTube and you type in Michael Pendazis, you'll find my YouTube channel and I have playlists. And so if you go to the playlist for fall 2021 linear algebra, fall 2021 math 231, right? You go to that one, or math 231 fall 2021. You go to that playlist and I'll have the videos for this course on there, okay? Okay, so then again, you just need to wait a little bit for me to upload the videos on there. Right after class, it won't be on YouTube. Once I have time to upload them onto the site, YouTube, then it'll be on the playlist, okay? And so So what you'll be able to do is you'll be able to go to lesson notes, get the Word file and whiteboard notes on these folders, and you'll be able to go to YouTube and get the videos of the lesson recorded. Okay, Faizan said he will remind me, right? Okay, so Faizan, you'll remind me to record the lesson at the start of class, right? So then he'll make sure I start the recording, and then thank you, and then I'll record the lesson. Okay, and that's what will be on YouTube. Okay, so again, with the review lessons, there will be review. I think I did answer that. Okay, for Zana. For Zana? Or is, okay, so I don't know. Do you want me to say Faizan, or that's not right? It's Fart. It's
Professor, it's Farzana.
Oh, two names are just very similar.
Yeah, it's very similar. That's why I say low to Faizan.
Oh, okay. Wait, so who's reminding me? Farzana or Faizan?
Yes, Professor, it's me, Farzana.
Farzana, okay. Okay, thank you. Farzana, okay. Farzana, got it. Sorry. Oh, and Farzana, your screen name is Sabrina.
My screen name is Sabrina?
No, it
says... Sabrina is someone else.
Oh, Sabrina was talking about your name. Got it. Okay, got it.
Thanks.
Farzana, good. Got it. Okay, you're in the kitchen. Okay, that's interesting. Okay, so, okay. I don't know. It's just nobody has their video up. So then you had yours up, and I saw a kitchen. And I was like, oh, okay. That's the only thing I'm going to see for the next hour. Okay, so, okay, if anyone wants to put their video on, please do. It makes it better for me because then I'm not teaching to names on the screen for 2 hours. You know, it makes it more personal. Okay. Okay, so Farzana's going to remind me. Fantastic. I have so many things to remember. Okay, so those are the lesson notes. And if you go to tests, okay, so you go to tests here. There's 3 exams during the semester and the final. So there's a folder for each of the 3 exams and for the final. If you click, let's say test 1, right? For test 1, there's a review sheet for test 1. And so if you click that, what will come up will be the review sheet for test 1 here. Okay, I think you can see it on the screen, right? Okay, so this is the review sheet, and it says linear algebra review sheet for test number 1, things to study. First thing, chapter 1, systems of linear equations and matrices. Read the following sections in the chapter and work on the following problems. So this is for review for test 1. Okay, and so it has each of these 9 sections and review problems for those 9 sections. And then the second thing is chapter 2, determinant. Read the following sections in the chapter and work on the following problems. And so there's 2 problems for each section. Okay, review your lecture notes and homework answers also. Okay, so this is a review sheet to give you review problems and to help guide you on how to review, how to study for the exam. Okay, right, so every problem giving a review sheet is not giving too many problems, but not too few. So, you know, okay, so there's that. Okay, so you have a review sheet, and then, so you have a review sheet, and then there's a practice test. So if you click practice test 1, this is a practice test for the first exam. So this was an old test 1 I gave. So you have 1 hour to take the exam. Each question was 20 points. So the structure of this exam will be the same. It will be the same. You'll have 1 hour, and each question will be worth 20 points. And so these are 5 questions from an old exam. Each will worth 20 points. And so you can do this practice exam. You can take it when you feel ready to. You shouldn't take it too soon. And then after you're done, you can click answers. And then I typed up, and then these are the answers to those 5 practice questions. Okay. And so you can see how you did. Okay. So that's for test 1. So in the test 1 folder, there's a review sheet, question problems so you do the review, and then there's a practice test and then the answers to those practice tests. Okay. So that's for test 1. Then if you click the test 2 folder, there's a review sheet for test 2. So if you click that, were you able to see the stuff I posted before? So this is the review sheet for test 2. Again, the sections, the study and problems, the study for test 2. Then if you click practice test 2, I think you can see this, right? This is a practice test for test 2. There's 5 problems. They're each worth 1 hour to take the exam, each worth 20 points. Structure is the same. Okay, and then answers to practice test 2. That's another screen. And you see that on the screen there. And so then you can go over your answers and make sure you got it right. Okay. Okay, that's for test 2. And then if you go to tests and you go to test 3, this is the review material for test 3. So review sheet for test number 3, you click that. This is becoming redundant. Now, these are the 4 chapters that's on test 3, and these are corresponding problems for the sections from those chapters. Review your lecture notes also, right? Okay, so that's the review sheet. So I put them in the order of the way I think you should do it. You should do the review sheet first, then you should do the practice test. Then you should do the practice test. Oops, what's going on here? Why did that go to print? I don't know why. Okay, it's not printing. So then this is the practice test for test 3. Okay, this one was a little long. It'll fit on the screen when you take your exam. Okay, and then those are 5 questions. And then after that, you can look at your the answers and see if you got it right. Okay, and so that's for test 3. And these are the answers to test 3. Okay, a little slanted, sorry. Okay, so okay, and so that's my suggestion to how to study. Do the review sheet first, then the practice test, and the practice answers. So this is for the 3 exams. And then the final is last. And so for the final, there's a practice final, okay? And so these are the 10 questions for the practice final. And so the structure is that there are 2 hours to complete the exam. Each question is worth 10 points, okay? We'll have a review for all 3 exams, and we'll have a review for the final, and I'll go over, answer any questions you want from the practice final. I can go over all the problems if you want, some of them, whenever you want to, okay? Right, so, okay, so that's review material for all 3 exams and the final. So I'm giving it to you now, so you have it now, okay? I usually give about 2 weeks advance notice for every exam and final. So you have 2 weeks advance notice, but you can start studying whenever you want. So, you know, we're covering material you can study in advance, and you'll have 2 weeks advance notice for the exams and final. Okay, okay, but you have more than 2 weeks for the review sheets and stuff. Okay. Okay, so there's rules for exams and what to do to take an online exam. So if you click this for rules for an exam, this file will open up. And so this is about the rules to take an exam. Okay, so it's a whole bunch of stuff. So for homework for next Tuesday, what I want you to do is to read all of these rules. Okay, so that's one of the things for homework I want you to do. Okay, for instance, the first one, it says the exam will be on Zoom and you're expected to arrive on Zoom to start a class on test days. You will use the scheduled class link that is used every class day to also attend exams on exam days. Okay, so then just read all this. These are the rules for taking an exam. And this explains things you need to know about taking an online exam for this course. Okay. Okay, and then another link is what to do to take online exams. I want you to read that also. So for homework for next Tuesday, I want you to read this file also. Could you see that other file before? Okay, so here, this is what you need to do to take an online exam. So read all of this. And the first one, download Zoom onto whatever device you're using to take the exam. The device that you use will need good audio, good video, and a video camera. You'll also need a reliable internet connection. Okay, so and then read all of this. That will explain things about. So I want you to read that for next Tuesday. Okay. So here, when I click rules for an exam, I don't know if that was on the screen when I was talking about. So let me just quickly go to rules. Here's the rules for exams, right? And so I want you to read this also. So rules for an exam, I want you to read what to do to take an online exam. Read these 2 files. Also for homework, I want you to read the syllabus that I just showed you, okay? So these 3 things, you click this link and you open it, and that'll have everything here. Okay, so read those 3 files for next Tuesday. Okay, and that explains what's happening in the course, what will happen. Okay, oh wait, the syllabus is here. Nope, that's not what I want. New share. Nope. Here, this is what I wanted. Right, and so the syllabus I also want you to read. So I want you to read the 2 other files, read the syllabus, and read these 2 files. Read all 3 of them for homework for next Tuesday. Okay. Discussions. This is just a discussion board. So if you have questions you want to ask me about the course, you can post the question here and I'll answer it. There's also my email address, and that's the preferred way. So if you have questions, really the best way is to send me an email so we can talk about it. But this is a second way for you to be able to communicate with me during the course, and it's through the discussion board. Okay, my contact info. Let me just make this visible to you because I made it invisible. Make the profile available. Okay, so this is now available. Okay, so when you click Professor contact info, here it is. So that's my email address, michaelpendazis2021 @gmail.com. That's the email I'm using for the entire course. If you need to contact me there. When you take exams, right, it'll be on Zoom. And so you have to come at the start of class time. I'll proctor the exam. It'll be an hour exam, right? For the 3 exams, it'll be an hour exam. And so at the end of the exam, you'll have to email me your answers, right? And so when you email me your answers, you're going to be sending the email to this email address, michaelpendazis2021 @gmail.com. Okay, so you send your email to that email address. Send your exam just once by email. Okay, some students need to send in multiple emails. That's fine. By sending just once, I mean don't resend something in another email, right? You send everything once. I'll have a Zoom meeting about 45 minutes after the exam, where I'll tell people I received their exams by email. So if you're worried about whether or not I received it, I will confirm with you. I'll tell you I received all your test answers by email. If you ask me, if you come, right? And so that's why you only need to send it once. You only need to send it once because you can come to that meeting and I'll tell you whether or not I got it. If I didn't get it and it's 45 minutes after you're at that Zoom meeting and I'm looking, I don't see it, if there's a problem, I'll just tell you to resend it. So there won't be a problem, okay? If you don't do anything to adjust the problem and it's like the next day, then there's a problem, okay? But if you do the exam, you're here, you do the exam, you send me the exam, and there's a problem with being sent, but you come to that meeting and we talk about it, you'll be able to resend it and there's no problem at all. Okay, if you can't make it to that meeting, I do confirm that I received exam answers right after the exam, after they send it, okay? So you have to send your exam right after you take it, right? So you have to send your exam answers right after you take it. So if you send it right afterwards and you stay on the Zoom meeting, I'll confirm with you whether or not you received it, right? You can't leave after the exam and check with me the next day, okay? So you have to, if you can't make it 45 minutes after, I will tell you whether or not I received it right after, but it's only for students who can't make it 45 minutes after, okay? Right, if there's 3 students who need it to be checked right away and there's 30 that don't, then checking with the other 30 when there's 3 students who can't make it later doesn't make sense, right? It doesn't help. So only the students who need it to be checked right away, I'll check right after. Okay, but you need to then, if you need me to check it right after, you have to send it quickly, right? It can't take you 20 minutes to send the exam if you need me to check it right after. Okay, so keep that in mind, okay? So you have to make sure you read the rules for the exam, how to take an exam, all of that. So that way you have everything figured out before the start of the exam. And so if you know what you're doing and you practiced it, you can send an exam in 5 minutes, right? If you don't know what you're doing, if you didn't rehearse ahead of time, it might take you 40 minutes. I don't know. There might be problems, right? One of the things I mentioned in the file is that there's an app called Genius Scan. You can download on your phone and then for free, and you can use that to save your entire exam as one PDF file, and it sends in a single email. So that's how I suggest a lot of students do. Maybe some students don't have a cell phone or can't do it that way, then you have to do something else. But for a lot of students, you can download Genius Scan for free as an app on your cell phone and send me all your exam solutions as one PDF file, okay? If you take just pictures with your phone, that takes up a lot of space. And so you can't send me all your exam answers if you're doing it by taking normal pictures. You have to really send it, you need to send it like in a PDF that can be compressed into a smaller size file that can fit in one email, because email addresses have a maximum storage amount, right? So it won't allow you to send 7 regular pictures with yourself that you took on your cell phone on. Okay. The app is called Genius Scan. So the app is called Genius Scan, okay? So the app is called Genius Scan. Put in 2 because Genius Scan, they answered by itself. Okay, so it's called Genius Scan. You can try doing that after class. You can ask me questions about it too. If you tried to download it, if you tried to make it work and you have a question about it, you can ask me about it. Okay, so try to get that working.
Professor, that's the problem I faced in my last semester. I couldn't like send multiple pictures together after my test, and I think it was because of because of Outlook too, because it was not supporting my pictures. So I had to send my professor multiple pictures of the document.
Do you have a cell phone?
Yes, cell phone.
Okay, you have an app, right? You can download apps on it?
I mean, yeah, but iPhone has its own, like we can scan in our built-in scanner.
Right, but yeah, I mean, everyone has their own other ways to do it. There's one way I know that works. So if you were asking me how to do it, I would tell you this way works. If you download the app Genius Scan, right, on your cell phone, it's an app and it allows you to just take pictures on it, but it'll scan it. And then all the pictures you take save as one PDF file. And then you can send all of your answers in one PDF file in one email. Okay.
Okay, Professor. Yeah, we'll try that. Thank you.
Try that. What I would suggest is like take like a bunch of pieces of paper and then download the app and try taking a picture of all of them and then saving it as one PDF and try sending it to yourself and seeing if you can do it. And then if you can do that, then you can send it to me after the exam.
Thank you, Professor.
You're welcome. Okay, thanks for participating. Okay, there's something in the chat. There's something on notes. Like if you go to your phone and there's notes, you can go into notes and then you can, it's like more complicated. It's not hard, but like it takes a little bit more thought. It's a little bit, Genius Scan is simple because it's just an app. And once you have the app, you just open it and it's very user-friendly. So Genius Scan is like more user-friendly. And so as a teacher trying to explain 30 people how to do it, notes would be a more complicated way to explain to 30 people how to do something. Genius Scan, you just download the app and take pictures. It's much simpler. Okay. So also I mentioned that there's office hours every week on Friday, right? From 2:15 p.m. to 3:15 p.m. And it's on Blackboard Collaborate Ultra. So if you go, when you're on the Blackboard page, if you click on Blackboard Collaborate Ultra, that will bring you to a list of scheduled Blackboard Collaborate Ultra meetings. And so I scheduled every office hour for the semester on here. So it's every Friday from 2:15 p.m. to 3:15 p.m. The meeting is here, right? The meeting does not open until right before the meeting starts. So I think it's like 15 minutes before the start of the meeting, you can then join it, okay? I'm not gonna probably be in the meeting early, so I'll be there at the time. But if you wanted, you could join the meeting a little bit earlier to make sure you're on time, okay? Try to be at the office hour like on time. If you wait in the last 5 minutes, right, I may have to go, right? So the later you attend an office hour, the less I can help you, right? So try to attend at the beginning. Okay, so so every office hour is on the office hours on Fridays from 2:15 p.m. to 3:15 p.m. It's one a week. There's a few weeks where the college is closed on Fridays, which means there can't be an office hour on that day for that week. So for those days, I rescheduled the office hour to another day of the week at a different time. So there's still an office hour for that week. So for instance, September 2nd, September 3rd is a Friday and this college is closed. So I rescheduled the office hour for that day to September 2nd, the day before, from 5:15 p.m. to 6:15 p.m. Okay, so for next week, we can't have office hour on Friday. And so it's going to be on Tuesday from 5:15 p.m. to 6:15 p.m. You don't have to memorize this. You just click Blackboard Collaborate Ultra and you can see the next meeting when it's going to be. And you can see future meetings. So if you want to, if you're saying to yourself, well, I don't want to come to office hour this week. Maybe I want to come to office hour next week or something like that. You can see when the office hour is for that next week and plan out how you'll make it, okay? If you can't make office hours and need my help, just email me and tell me, and then I can figure out a way to meet with you and help you at another time, okay? So office hours are from 2:15 p.m. to 3:15 p.m. and they keep being at that time because there's colleges open on those days. And then on December 23rd, there's an office hour from 5:15 p.m. to 6:15 p.m. That's because on November 26th, the college is closed. It's a Friday. So November 26th is a Friday and it's closed. And so I rescheduled that one to earlier in that same week on the 23rd, which is a Tuesday. Okay, so for that week on Tuesday from 5:15 p.m. to 6:15 p.m. is the office hour for that week. Okay, and it goes back to normal with 2:15 p.m. to 3:15 p.m. to the end. Okay, so those 2 days were rescheduled because the college was closed. Okay, so that's how it worked. You'll just click the class meeting link. You'll be on Blackboard Cover Ultra. I'll be there, and then you'll ask me questions, and then I'll post. Like you asked me a question about how to do a problem, I'll write down the solution, and I'll post it on the screen, and I'll explain to you the solution on the screen. Okay, so that's how Blackboard Cover Ultra will work. I like the fact that there's a link here that brings you to Office Hour, which is why I like having the sessions this way instead of on Zoom also. Okay, so this is a student starter guide for you. If you want it, it can help you know how to use Blackboard. Okay, Queens College Library Resources, you click that, tools and help. So that's for you. Below that is just stuff for me, but it's just links. So this is the stuff you'll see in your page that you can use. Okay, and so I went through Blackboard for you. That's how you use the Blackboard site for this course. Okay, and then the lessons will be on Word. And so what I'll do is I'll be typing on here real time. So you'll be here, I'll be typing. And so then I'll be saving it. And so at the end of the lesson, you'll have, there'll be a saved Word file that I will post on Blackboard. And then so you can go on Blackboard onto the lessons folder and it'll be there, okay? If I do use whiteboard notes during the lesson, then I'll save the whiteboard notes and put them on that folder also under lessons. Okay, so you have the Word file, the whiteboard file, and then I'm recording the lessons. Blackboard is unreliable with saving videos. So the solution I made was I have a YouTube channel called Michael Pendazis, my name. You go onto that YouTube channel, and then I made a playlist like Math 231 Fall 2021, something like that. You find a playlist for this course, and then you click that, and then all the videos that I've saved will be on there. Okay, so right now the playlist is empty because we haven't had any classes yet. And then every time there's a class, I'll then later upload the video onto YouTube. And so you'll be able to view all past lessons by video on there. Okay, so you have the video on YouTube, you'll have the Word file notes, the Blackboard and the whiteboard notes there also. If another file turns up, I might put that also on for a lesson. Okay, it may or may not. Okay, but the stuff that we do in lessons will be there. Okay, any questions about anything? Okay, no questions. Okay, someone just joined now. Okay, so well, actually, that's unfair. Sometimes internet doesn't work and people have to re-sign it. Okay, so now I'm going to take attendance. Okay, so let's do that. So what you'll see in the screen is just this at the moment. So I have my attendance sheet open now. So okay, so what I'm going to do is I'm going to call out a name. I don't want you to use the chat right now. What I want you to do is I want you to say, turn on your audio when you hear your name and say, I'm here, like that. Okay? So let's do this. Using the chat will just make this hard. So let's try to stick to the audio. Samaya, Alam, are you here?
I'm here.
Thank you. Okay. Oliver, are you here? Oliver James Al Madani Bellinson?
Yeah, I'm here. Yes, hi.
You're here? Okay, great. Okay, Eldon, are you here? Eldon Cando Marquez, are you here? Okay. Alan Savalos, sorry.
Here.
Yep, I see you. Thank you. Edgar Chang, you here?
Here.
Thank you. Wenzu Chen, are you here?
Here.
Thank you. Erkan Kamlecki, sorry.
I am here.
Thank you, I see you. Okay, David Cristobal, you here?
Yeah, I'm here.
Thank you. Mershad Eshagyanpur, sorry.
Yes, I'm here.
Thank you, I see you. Khairul A. Fahim, are you here?
Yes, I'm here.
Thank you. Okay, your audio is Cody Futch, are you here?
Here.
Thank you. Ahmed M. Hassan, are you here? Ahmed? Hassan? Ahmed M. Hassan, are you here? Faizan Hussein, are you here?
I'm here.
Thank you. Okay, your audio is a little staticky. Kader Jahangir, are you here? Qader? Kader? Jahangir, last name? Kader? Okay, Muhammad A. Khan, are you here? Muhammad? Okay. Marlon Lewis? Marlon? Saqib Mahmood, are you here? Saqib Mahmood, are you here? Okay, Alejandro Mandujano, are you here?
Here. Yep, I'm here.
I see you, thank you. Iana M. McCabe, are you here?
Yes, I'm here.
Thank you. Adrian Medina, are you here? Adrian? Medina? Okay. Farzana Munir, are you here?
Here, Professor.
Thank you. Benjamin, are you here?
Here.
This is Benjamin Mushayokov.
Yes.
Thank you. Okay, sorry about mispronouncing. Angela Pfeffer?
I'm here.
Thank you, Angela. Okay. Avinash?
Here.
Thank you. Lauren? Rena?
I'm here.
Thank you. Sabrina Shelley, you here?
Hi, Professor. I'm here.
Hi, thank you. Harminder Sinj, are you here?
Here.
Thank you. Ezra R. Stern.
Here.
Thank you. Vianney Talapeko.
Here.
Thank you. Sorry, I'm mispronouncing your name. Maria Urena, are you here? Maria Urena? Kenny Vilches. Kenny?
Here.
Thank you. Nathaniel Wiradiraja.
Yeah, I'm here.
Thank you. Okay. Kevin Zia, XIA. Kevin? Kevin? Okay.
I'm here.
This is Kevin?
Yeah.
Oh, okay, good. Thank you. Nursultan Zumabayev.
I'm here.
Thank you. Okay, I see. Okay, Leia Zupidis.
Yes, here.
See you. Okay, there we go. Thank you. Okay, a few more questions. Anyone who did not hear their name? Who's here?
Professor?
Yes.
Yeah, so I'm having internet connection problems. I'm not sure if you called my name, but I'm Maria Urena.
Yeah, okay, I did, but that's okay. I got you now. Maria Urena. Good. You've been in my class before. Okay, so.
Yeah. All right, thank you.
You're welcome. Okay.
Professor, me too.
Okay,
Terry Zhou, ZHOU.
Okay, so that's a new name. Okay, let me put that in. Terry Zhou. Okay, did you just sign into the class? Did you just join the class recently?
I think it was like on Monday.
Oh, okay.
On Monday.
Okay, sounds good. So Terry Zhou, I got you here. You are here. That is not a problem. You're on the attendance list. You're good. Okay, so anyone else? Okay, so anyone else not hear their name called? Okay, so just Terry Zhou I added. So, and Maria Urena I got then after. Okay, so I'm gonna read the names of people who I still have blank here. Eldon, are you here? Okay, Eldon Cando Marquez, okay. Next name, Ahmed Hassan. Ahmed Hassan, are you here? Ahmed Hassan, okay. Kader Jahangir, Kader. Okay. Muhammad Khan, are you here? Okay. Marlon Lewis. Marlon? Okay, I don't see Marlon. Saqib Mahmood. Saqib Mahmood, are you here? Okay, Adrian Medina. Are you here, Adrian Medina? Okay. Okay. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I have 29 students marked present. So there's 31 participants. There's one person who's here in 2 places, right? Harminder, I think. Maybe. Is Harminder, are you here in 2 different accounts?
No, I was able to fix my audio for the computer, so I went off.
Okay, is there someone here in 2 accounts? It's hard for me to find which one is in 2 accounts because there's just all these names all over the place. Anyone here? Oh, Edgar Chang. Okay, Edgar Chang, you're here in 2 accounts. Okay, so good. So there's 29 different people here. Good. There's at least 29 different people here, and I have 29 people marked present. That means it's everyone. Okay, so that's the attendance. We're done with that. So at least at most. Okay, so that's the attendance. Okay, so I got everyone right. Okay, so welcome to Math 231. This is lesson 1. Let's get started now. Okay. So the first chapter that we're covering is chapter 1, which is on systems of linear equations and matrices. Okay, and so 1.1 is on an introduction to systems of linear equations. Okay, so first let's talk about linear equations. So recall in 2 dimensions a line in a rectangular XY coordinate system can be represented as an equation of the form. And so it can be represented as equation of the form AX plus BY equals C, where the condition is that A and B are not both 0. Okay, they can't both be 0. If A and B were both 0, you'd be saying that 0 is equal to a constant C. And so if C was 0, you'd be saying 0 equals 0, which doesn't give you a line. That just gives you the whole plane. And if you wrote 0 equals 3, then that wouldn't make any sense and you'd have nothing. So for A and B both 0, either the equation would determine the entire plane or nothing. And so that would not be a line. Okay, so in order to be a line, you need both A and B. I'm sorry, A and B are not both 0. One could be 0, but not both. Okay. That's in 2 dimensions. And in 3 dimensions, a plane in a rectangular XY coordinate system can be represented by an equation of the form AX plus BY plus CZ is equal to D, where A, B, C are not all 0. Okay, so you can express a plane in 3 dimensions by an equation AX plus BY plus CZ equals D. A, B, C, and D are constants. X, Y, and Z are are the unknowns that define the x-axis, y-axis, and z-axis, right? But A, B, C, D are constants, but the only condition is that A, B, and C are not all 0, okay? 1 could be 0, 2 could be 0, just not all 3, not all A, B, and C. There's not, you don't have that condition on D, it's for A, B, and C. Okay, for this equation, right? Here, C is different. Here, A, B are not both 0 for this equation, right? So to here, the A, B are different. These letters are separate. They're separate, definite discussions, right? Okay. So let's go to the whiteboard. So what I'm saying basically is that if you have the XY plane, right, and you want to look at any line in the XY plane can be represented by an equation of the form AX plus BY is equal to C, where not both A, B, not both 0. Okay, so every line can be expressed as AX plus BY equals C, where A, B are not both 0, no matter what line you're thinking of. Okay, so that's the idea of that. And then the other statement is saying that if you have the XYZ planes, you have the XYZ. Yeah, that was pretty good. Okay, so if you have X, wait, I'm going to put X here. I'm doing this by hand here on a mouse or my hand. Okay, so now you have X, Y, and Z. So if you have a plane, so for this plane, I'm going to use different colors so it stands out because it's a little bit more of that picture. So if you have a plane here, right? So to draw planes, what I often do is I'll draw this rectangle, right, which is not the whole plane, but then I'll draw arrows coming out of the plane. And so what that's signifying is that this is really going out in all directions. So it's going all to the left, it's going up this way, it's going to the right this way, and it's going down this way. So this thing is a plane. It's not taking up all of 3 space, but it's a plane that's spreading out in all directions, right? So imagine if you were in a room and you had a piece of paper, but instead of just a piece of paper, you extended the sides out infinitely far in those directions. That would not cover the whole room, but it would be an infinite flat surface that would be in that 3-dimensional room, right? Okay, so we have a plane here, right? And so a plane can be represented by an equation of the form AX plus BY plus CZ is equal to D, where A, B, C, not all 0. Okay? And so that would be a representation of a plane in 3 space. Every plane would have such a representation, and every representation would have a plane representing it. Okay? Plane with that representation. So there's a correspondence between these equations and planes. Okay? It covers all of them. Okay. And so that's the point of that part. Okay? So we have a way of representing all lines in 2 space and all planes in 3 space. These algebraic equations. Okay, so these are examples of linear equations. The first being a linear equation in the variables x and y, and the second equation being a linear equation in the variables x, y, and z. Okay, so by first equation, I mean this one, and by second equation, I mean this one. Okay, and so these are examples of linear equations. This is a linear equation in variables x and y, and this is a linear equation in variables x, y, and z. Okay, so a definition. More generally, we define a linear equation in the n variables x1, x2, and so forth, xn, to be one that can be expressed in the form A1 x1 plus A2 x2 plus dot 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 plus AN xn equals B, where the A's were A1, A2, dot dot dot, A sub n, and B are constants. And the A's are not all 0. By A's, I mean A1, A2 up to A, including ANs. And the A's are not all 0. Some of them can be 0, as long as it's not all. None of them could be 0. Most of them could be 0, just not all of them. And by that, I mean only the A's. There's no, I'm not placing a restriction on the B. Okay. In special cases where n equals 2 or n equals 3, we will often use variables without subscripts and write linear equations. As A1 x plus A2 y, by subscripts I mean for the x and y, equals B, where A1, A2 are both 0. So what I do is this, I'm just going to put all of these so that they're under the same indent. Very good, okay? And then where we could do A1x plus A2y plus A3c is equal to B, where A1, A2, A3, not all 0. Okay, so we could write linear equations as one of those. And this is if there's only 2 or 3 unknowns, whether x and y or x, y, and z, right? Because it's simple. If you were to have 20 unknowns, you would not want 20 different letters there, right? I'm just saying 20 in general. I'm not going to be doing 20, but we want a notation for any situation that occurs, right? And so even if there's 20, we won't say, well, there's too many, let's just stop. We can't do anything, but this is too complicated, we have to stop. The letters are too confusing, we can't do this problem. Right, so this notation is accounting for that. What if there were 20 variables, right? You couldn't have a different letter for all 20 of them. And so that's why these subscripts come into play. So you have x1, x2, up to including xn. And so the subscript notation is more confusing at first. Once you get it, it's much, much easier, because now you can see how many unknowns there are, right? And you can still differentiate between them. You can't call different variables by the same name. You can't say x and x again, right? And so you need the subscripts. The subscripts mean x1 is a variable, x2 is a variable, xn is a variable. The only significance of the subscript is to differentiate between them so that they're different variables. It's not making any kind of sophisticated argument, okay? I'm just naming n variables, each with a different name, okay? It's just easy to read. Okay, okay, so in the special case where b equals 0, equation 1, so let me label some of these equations. So this one I'm labeling as 1. Anyone's going to do that. Okay, let's put it here. Nope. Okay, put it after. That's equation 1. Okay, I'm not multiplying by 1. That's equation 1. And then equation 2 is this guy. Equation 3 is this guy. So sometimes I'll label things with these parentheses. And so that way, when I'm referring to something, instead of having to say the whole thing, I could say, you know, by 2 or by 1 or by 3 or because of 1, something like that. It just makes it faster to speak. So in the special case for b equals 0, equation 1, which is this equation, equation 1 has the form. And so it has this form. It has a1 x1 plus a2 x2. Right, see this equation? And so plus dot, 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 plus a n xn equals 0. Yeah, because we're just replacing b with 0. So it's equation 1 where b is 0. So then it has that form. And I'm going to call this equation 4. And so I'm giving it its own name for this reason. So it's special because, so it has its own name, it's special, which is called a homogeneous linear equation. In the variables x1, x2, up to including x sub n. This is a homogeneous linear equation. Okay, linear equation because it's like all these other equations. The word homogeneous is saying that it equals 0. Okay, so the equals 0 at the end is the homogeneous part of the name. Okay, this would be a linear equation if it equaled any b, and then when b is 0, it's then a homogeneous linear equation. Okay, as a homogeneous linear equation in the variables x1 to xn. And so these words, a homogeneous linear equation in the variables x1 to xn, that's saying you have a general equation of this form, where you have the variables x1 to xn, and you have a linear sum of those n variables, and you're setting it equal to 0. Okay, this is called a linear sum because you multiply each of your variables by constant and you add up those products. That's called a linear sum. And so setting a linear sum equal to a constant is a linear equation. And then setting a linear sum equal to the constant 0 is specifically a homogeneous linear equation. Okay. Okay, so let's go through examples. Example 1, linear equations. Okay, so the first example is linear equations. So observe that a linear equation does not involve any products or roots of variables. Okay, products of variables or roots of variables. So I'm going to put products of variables. You're multiplying the variables by constants, but you're not multiplying a variable by another variable. Okay, so observe that a linear equation does not involve any products of variables or roots of variables. Okay, all variables occur only to the first power and do not appear, for example, as arguments of trigonometric, logarithmic, or exponential functions. It does not. The following are linear equations. So for instance, when I put a 1 period here, I'm just making a list, right? But when I index something, it's in parentheses next to it. Okay, so this 1 is not the same as this 1. This is index. This 1 in parentheses is saying this is equation 1, right? This 1 dot might just be a list or be whatever it is. Okay, it's different. That's how my notes work. Okay, so 1, I'm making a list now of linear equations. The following are linear equations. So one example would be x plus 3y is equal to 7. That's a linear equation. Second linear equation would be 1/2 x minus y plus 3z equals -1. That's another example. The third example would be x1 minus 2x2 minus 3x3 plus x4 is equal to 0. It's another linear equation. Another example of linear equation is x1 plus x2 plus ... plus x sub n plus x sub n is equal to 1. So even though it's a ... right? When there's a ... it means you follow the pattern, right? So x1 plus x2 plus ... plus xn means the sum of all the x's from x1 to xn, and that's equal to 1. So those are 4 examples of linear equations, okay? In none of those 4 examples are you taking the trigonometric function of one of those variables. You're never doing that. You're never taking the logarithm of a variable, and you're never taking the exponential function of a variable, okay? Okay, so now, that doesn't mean that the log function can't appear, but it would have to be a constant, okay? You could take log of 2 times x, right? Log of 2 would be a constant, and you're multiplying it by x. You can't take log of x, that's what I mean. Okay, the following are not linear equations. First one is x. This is not a linear equation. X plus 3y squared is equal to 4. That's not a linear equation because we're multiplying the powers of every variable has to be 1. Okay, another one that's not a linear equation is sine x plus y is equal to 0. That's not a linear equation because you're taking the x, one of the variables is an argument of a trigonometric function that cannot happen in a linear equation. 3, this is also not a linear equation. 3x plus 2y minus xy is equal to 5. This is also not a linear equation because you multiply 2 of your variables x and y together. You can't do that in a linear equation. So that's not a linear equation. And then a 4th example of a non-linear equation is the square root of x1 plus 2x2 plus x3 is equal to 1. This is not a linear equation because we took the square root of x1 here. In exponential form, the square root of x1 is x1 raised to the 1/2 power. And so you can only have variables raised to the first power, in a linear equation, okay? I guess you could have it raised to the 0 power, but only because that's 1. Anything raised to the 0 power is 1. So ignoring the raised to the 0 power option, other than that, you can only have a variable raised to the first power in a linear equation. Okay. So a finite set of linear equations is called a system of linear equations, or more briefly, a linear system. Okay, so a finite set of linear equations is called a system of linear equations, or more briefly, a linear system. So when you have a finite set of linear equations, you can either call it a system of linear equations or a linear system, okay? That's a definition of one or either. The variables in such a system, the variables are called unknowns, okay? So the variables are called unknowns. Okay, so for example, system 5 so for example, system 5x let me put the system here. So for example, this system, which is 5x plus y is equal to 3. And it's a finite set of equations. So I have two equations. These two equations make up your linear system. Let me fix that out without screwing things up. Good. 2x minus y is equal to 4. Okay, so these two equations make up a linear system. Make up a system linear equation because it's a finite set of linear equations, right? There's two of them. That's finite, right? So this system has unknowns x and y, has unknowns x and y, right? The unknowns in this system are x and y. Okay. Another example. This system. And so now we're going to put another system here. This system is going to be 4x1 minus x2 plus 3x3 is equal to -1. And the other equation in the system is going to be 3x1 plus x2 plus x2 plus 9x3 is equal to -4. So this system has unknowns x1, x2, and x3. Okay. So this is 3 unknowns. Even though it's 2 equations, it has 3 unknowns. So the number of equations does not have to be the same as the number of unknowns. This was a system with 2 equations in it and 2 unknowns. This was a system with 2 equations and 3 unknowns. Okay, so each has its own amount. Number of equations and number of unknowns, so each of their own amounts. They can be the same, they can be different. One could be more than the other one could be more than the first. Okay, a general system, a general linear system of m equations in the n unknowns x1, x2, up to including x sub n, can be written as a11 x1 plus a12 x2 plus a1n xn is equal to b1. Okay, that's the first equation. The next equation is a21 x1, a21 x1 plus a22 x2 plus plus a2n xn equals b2. And then continues. So I'm going to put the ... to represent the fact that I keep making equations here. And then that continues. And then the last one, including all the ones in between, is am1 x1 plus am2 x2 plus ... plus amn xn is equal to bn. Okay, so this is a general linear system of n equations in the n unknowns x1 to xn. Okay, and so that can be written as this in this form. Okay, so the easiest thing to see is that there's these n unknowns, x1 to xn, right? You see that there's x1 to xn here, right? The a's are the constants and b's are constants, right? So the a's and b's are constants. The x's are different unknowns that are differentiated, that you can tell are different because their indices are different, okay? All right, so you have x1, x2, up to including xn, right? So you have only those. You have even more a's though, right? Because you have 2 indices here, okay? So you can see that there are exactly n unknowns in this general system. The next easiest thing to point out is so each of these linear sums on the left are equal to their own constants on the right. So B1 is the constant for the first equation. B2 is the constant for the second equation, up to including Bn is the constant that the left side is equal to on the nth equation. So there are n equations, right? There's the first equation, the second equation, third, fourth, up to including the nth equation. Oh, wait, sorry. That should be an M. Okay, so that should be an M. So there are M equations, first, second, third, and so forth, including the mth equation. Okay, so there's M equations. And so that's why you have MBs, B1, B2, including BM. So those are the B's on the right side. The B is used to say, okay, you're looking at the right side of the equation, and the subscript is differentiating between the M constants on the right side of those M equations, okay? So hopefully it makes sense that there are n variables, x1 to xn, in each equation, and each equation has a constant that's equal to the right-hand side. Each of them has their own B's, so B1 to Bm. N unknowns, which are the n x's, and m b's, B1 up to including Bm, because there are M equations. M equations, n unknowns. Okay, hopefully that makes sense. Now the A's is the most difficult part, but the A's are just the constants at the end of the variables for each equation. Okay, so there are M equations. Each of the M equations has the n unknowns, right? So all M equations has all n unknowns in them. And each one of those n variables in each equation is multiplied by a constant. Those constants are all different, okay? And so the subscript notation is just a way of orderly representing all of the coefficients for all n variables in all M equations, okay? So the subscript for B is easy because there are M equations and there's only one unknown on the right-hand side of each of the M equations. And so you can represent the constant on the right-hand side as B1, B2, up including Bm. M equations, MBs on the right-hand side. The A's are a little bit more complicated because for each equation, there isn't just one A, there's n of them, okay? So for each equation, you have A constants on the left-hand side. You have n of them, okay? But there's M equations. So you have M equations. For each of the M equations has little n number of coefficients on the left-hand side. So the A's are the coefficients and B's are on the right side, right? Okay, so this is how the indices work, okay? You don't have to memorize the indices system. You have to understand it. When you understand it, then you don't have to memorize anything. You can just write this whole thing down and have anything memorized and it'll be right. That's if you memorize it, if you understand it correctly. Okay, so these are the A's, right? So for instance, the first equation, which you can tell because it's a B1 here, the first equation, the first index is going to be the number of the equation you're in. So the first index for all of these A's is 1. So this is A11, this is A12, up to including A1n. So the first index is telling you which equation your A is in. For instance, the second equation, you have a B2 on the right-hand side, right? But also in the second equation, the A's is A21, A22, up to including A2n. The first index in every A in the second equation is 2, because these are coefficients A, these are coefficients in the second equation. And the last equation is the mth equation. You can tell because there's a Bm on the right-hand side. The mth equation, the first indice in all the A's is an M. So this is AM1, this is AM2, up to including AMN. So the first index is always telling you which equation your coefficient is in. Okay, so the first index is the equation in which your coefficient lies in. So A11 is a coefficient in equation 1. A1n is also a coefficient in equation 1. But the second index is differentiating between different coefficients in the same equation. Okay, so even though they're both in the same equation, they're different coefficients in the same equation. And so they need additionally something to differentiate between them. So the first index tells you which equation it lies in. The second index tells you which variable it is a coefficient of, okay? So we have n unknowns. We have n unknowns. We have x1, x2, up to including xn. And so each of the m equations has those n unknowns, okay? And so corresponding to those n unknowns in each equation is a coefficient. And you can tell that it's the coefficient of that unknown because the second index tells you the coefficient of which variable. It's a coefficient of which variable. So the coefficient of x1 has a second indice of 1. The coefficient of x2 has a second indice of 2. The second index for the coefficient of xn has n as the second index, okay? So first equation, first indice for all of them is a 1 because they're all in the first equation. But there are n unknowns, and each of those n unknowns has its own coefficient, and each of those coefficients are different from each other. They could be equal, they could not be equal, but you need a different variable, you need a different letter to represent each of those coefficients because there is no direct relationship between them. So you need a symbol to represent each of them. And so the second indice is telling you it's a coefficient of which unknown. So A11, the first equation, second one, coefficient of x1. A12, the 1 is, it's in the first equation. The second index 2 is its coefficient of x2. The last one, A1n, tells you, well, it's in A1n is a coefficient in the first equation, and it's a coefficient of the nth unknown. So that's why it's A1n xn, A11 x1, A12 x2. The 2 corresponds with this 2. The second one corresponds with this one. The n here corresponds with that n. See that? And for the second equation, A22 x2, well, it's in the second equation. So the first indice tells you it's in the second equation. And the second indice, which is also 2, tells you it's the coefficient of the second variable. Okay? So AM2 x2, what that tells you is that AM2 is a coefficient in the mth equation, and it's a coefficient of x2 in the mth equation, okay? The m tells you which equation it's in, the 2 tells you its coefficient of x2, okay? And so in that way, you have m times n number of a's. You have m times n number of coefficients, and you have m number of constants at the end, okay? And so this is a general form. This is the form of a general linear system of m equations in the n unknowns x1 to xn, okay? So for any linear system that has n unknowns in m equations, you can choose it so that your coefficients correspond with these a's, your unknowns correspond with these n unknowns, and the constants at the end correspond with these b's, okay? So, I mean, if you change the order of the products, right? If you change the order of the equations, you could just switch the order back so you could express the same linear system in this form, okay? So whenever it says can be written as, can be expressed as, what I'm saying is that if you tried to make your system look weird, if you tried to make your equation look weird by switching the order, making x1 plus x3 plus x2, for instance, equals 2, that still fits this description because you can express that as an equivalent system that says x1 plus x2 plus x3, okay? So the wording is not, it is exactly this. It says can be written as this, okay? So a general linear system of m equations in the n unknowns x1, xn can be written as that, okay? When I was learning this, I spent some time thinking about that because I thought, like, I like that. It can be written as, right? The definition has to be general enough so that you change things, but when you change things unnecessarily, it doesn't matter, right? It doesn't matter if you do x1 plus x3 plus x2 equals 1 or x1 plus x2 plus x3 equals 1. It really doesn't make a difference, right? And so we don't care about that in this general definition, right? That's why we say, instead of saying it is, it can be written as. That's what we want, okay? Saying less is more a lot of times. Usually, or very often, saying less is more. So saying can be written as is better than saying it is exactly this. Okay. Okay, so that is a general expression of, that is the expression of a general linear system, m equations in those n unknowns. Okay, so I'm seeing in the chat, there's a question. Erkan, is there a way to tell the difference between a 1-to-1 and, a 1-1 and a 11 since they're written the same? So sometimes people would put commas. You could put a comma, but You don't have to usually. So a lot of times in life, this happens, and in math too, it's about something, a lot of times it's about context, right? If you see a system where there are only 3 equations and you see A11, it can't possibly be an 11, right? Because there are only 3 equations. So usually context gives you the obvious answer to it, right? And when I was first studying math, I thought that it shouldn't be about context. It should say exactly what it is. But it's better if you look at it in terms of context, because you're never going to write everything. Oh, you're welcome. I guess I'm going on a tangent. You're never going to write everything that needs to be said, right? If you write everything that needs to be said, you're going to write pages and pages of things when you just want to say something really easy, right? If you just want to tell somebody something, you want the person you're talking to assume things, not to read everything you're saying, right? So if you were to put commas in all those places, right, that would be a waste of time, right? Right? Do we want to put, if there are 5 equations, if there are 3 equations with 3 unknowns, right? That means you have 9 A's on the left-hand side. Do you want to write 9 commas, right? You'd rather not put 9 commas. So with assuming a little bit from the reader, you can then not have to write 9 commas, right? So we don't want to say, okay, well, what's the difference between 11 and 1, 1, right? I mean, there is a difference, and technically, I'm not saying the difference. You have to understand it. You have to read into the difference, and it's better that way, because you don't want to write 9 commas when you could write 0 commas by just assuming that there is no 11 in the problem. Okay, I answered that question. Okay, so yeah, that's right, for zeta. So the first one is the number of the equation that the coefficient sits in. The second index is the coefficient that it corresponds, is the variable it corresponds to. So A11, the first one is for equation 1. The second one is it's a coefficient of x1. A12, the 1 is for first equation, 2 is for coefficient of the second variable x2. Okay, and yeah, a single equation is also considered a linear system. So the definition of a linear system, remember the definition of a linear system is that, oh, here we go. A finite set of linear equations is called a system of linear equations. So all that's required in the definition is that you have a finite number of equations in your system. And so if you have 1 equation, 1 is a finite number. And so having 1 equation does constitute an entire linear system. Okay? It's not interesting, right? Why even call it a system? It's just 1 equation. You might just say, okay, I have a linear equation, right? But technically, it is a linear system. Okay? So yeah, so a single equation is considered, well, a single linear equation, right? So the question by Harminger was, is a single equation also considered a linear system? It can be if it's a linear equation, right? Not every equation is a linear equation, right? If that one equation was x squared equals 5, then no, it is not a linear system, because x squared equals 5 is not a linear equation, right? We want a finite set of linear equations. So the fact that it's 1 doesn't matter. You can have 1 equation, but it has to be a linear one. That makes sense? Oh, yeah, okay, good question, very good question. All right, those are all good questions, right? It's fair to ask, is there a difference between 1, 1, and 11? And so hopefully my answer makes sense, is that it's better to assume, it's better to read that in context. It's better to read that in context than to tell the reader 1, 1. It's faster. You don't want to waste time with that. Okay, so a solution of a linear system in n unknowns x1, x2, x3, ... x sub n is a sequence of n numbers S1, S2, S3, ... Sn, for which the substitution x1 equals s1, x2 equals s2, dot, dot, dot. Wait, x2 is equal to s2, dot, 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 xn is equal to sn, which that substitution makes each equation a true statement. For example, the system in 5 has the solution x equals 1, y equals -2. And the system in, oh, wait, sorry, hold on. Let me label x equals 1. Okay, so this is 5. Yeah, but by 5, I mean system 5. Okay, referring to a system. 5 is referring to this whole system. Okay, so you have this system here, these two equations that form a linear system, 2 linear equations that form a linear system. The system in 5 has this solution, x equals 1 and y equals -2. So if you were to plug, let me just delete that for a second. Let's stop there for a second. X equals 1, y equals -2. So if you plug in x equals 1 and y equals -2 here, you get 5 times 1, which is 5, plus -2, which is 3. So you get 5 minus 2, which is 3. Also, if x is 1 and y is -2, you get 2 minus -2. And 2 minus -2 is 2 plus 2, which is 4. So x equals 1 and y equals -2 is a solution to this linear system because you can plug in this value of x and this value of y into all the equations, all the linear equations of that linear system, and they're all true, right? If I plugged x equals to 1,000 and y equals 0 into that equation, you see that that would not hold, right? You cannot do 5 times 1,000 plus 0 equals 3, right? And so x equals 1,000 and y equals 0 is not a solution of this equation. And so it is not as a solution of every equation. And so it is not a solution of this linear system. A solution of a linear system is an assignment of all the unknowns to values that satisfy every equation in the linear system. Okay? So that's what's happening here. A solution of a linear system in n unknowns, x1 to xn, is a sequence of little n numbers, s1 to sn, for which the substitution x1 equals s1, x2 equals s2, and so forth, xn equals sn, makes each equation a true statement. That's just saying that, for instance, s1 here would be 1, and y and s2 here would be -2. Okay. Okay, so this is the definition. This is a definition. Definition, a solution of a linear system in n unknowns. So I guess I'll put the entire underline. So a solution of a linear system in n unknowns, x1 up to including xn, is a sequence of little n numbers. So the solution is the values that you could plug in for all of the unknowns that would satisfy every equation, okay? If you plug in a value for x and a value for y and it satisfies the first equation, you can't choose different values of x and y to satisfy the next equation. They have to be the same values of x and y for every equation. And then that is a solution of all the linear equations in that one linear system. And so that is a solution of a linear system. That make sense? Okay. So that's what the assignment means. The S1 Sn is assigning values of all the unknowns in your linear system. So that if you plug in that assignment to every linear equation of the system, all of them are true, okay? And so in order to have a solution of a linear system, the assignment has to work for every equation. If there's one equation where the assignment fails, then it is not a solution of the entire linear system, okay? Okay. So for example, in the system in 5 has that as a solution. A solution, more succinctly, I'm going to stop in a minute because class is more succinctly, the solution more succinctly can be written as the ordered pair 1, -2. The solution directly above for linear system 5 more succinctly could be written as the ordered pair 1, -2, where the 1 is for the first variable, then the value I'm assigning to the first variable, and the -2 is the value I'm assigning to the second variable, okay? This is all about communication, okay? In the ordered pair 1, -2, right? It's technically not saying x equals 1 and y equals -2, but I'm communicating with you that, okay? So the goal of language is communication, right? So the point of 1, -2 is not to say, well, x is the first component of an ordered pair and y is the second, right? It's just to tell you, okay, well, instead of writing x equals 1 and y equals -2, we're making an obvious understanding that x is the first, y is the second. And so 1, -2 tells you x equals 1 and y equals -2 without writing as much, okay? So the goal of notation is to quickly communicate information to the reader. And when you understand mathematical notation well, in the beginning it's confusing and you can be confused. Once you understand mathematical notation, you can actually, it's actually easier to work with mathematical notation, because if you have to explain something to someone in a paragraph, or instead you could write it using a few symbols, the person would understand it better with just a few symbols if that person understood what those symbols meant. Okay, so mathematical notation doesn't just speed up how quickly you're doing mathematics, it's also speeding up how quickly you can understand mathematics, right? And so it's making it easier to understand. Okay, so with all this weird notation, it's making it, in the long run, it's easier to understand math this way. Okay, so we're going to stop there. So this is so we'll stop here. I've been recording this whole lesson, so I'm going to